According to the National Electrical Code, grounding rods for service and lightning protection must be spaced a minimum of 6 feet apart. The reason for this requirement is to prevent interference between the rods, which can reduce their overall effectiveness. When grounding rods are placed too close together, their zones of influence can overlap. This overlap can diminish their ability to effectively dissipate electrical current into the earth. The principle at play is that each grounding rod creates its own electrical potential field in the surrounding soil. When these fields interact, it can lead to a reduction in the overall grounding system's performance. It's important to understand that the National Electrical Code sets minimum standards for safety and proper functioning of electrical systems. Adhering to these standards is crucial for protecting people and property from electrical hazards. The engineers claim that the close proximity of the rods will cancel each other out is not entirely accurate. While it is true that grounding rods can interfere with each other, this interference is most significant when the rods are extremely close, generally less than 3 feet apart. When rods are closer than 3 feet, the electrical field surrounding them can significantly counteract each other, leading to a substantial reduction in the grounding system's ability to dissipate current. Even if the rods are not close enough to completely cancel each other out, their effectiveness can still be reduced. The presence of one rod can alter the electrical field around the other rod, making it less efficient at dissipating current. This altered electrical field can impede the flow of current from one rod to the other, thereby reducing the overall effectiveness of the grounding system. In essence, the optimal performance of a grounding system relies on each rod being able to function independently to some extent. By ensuring adequate spacing between the rods, you minimize the interaction between their electrical fields and maximize their individual contributions to the grounding system's overall effectiveness. Reworking the grounding system to meet the National Electrical Code requirements is essential for ensuring electrical safety and proper system function. Firstly, move the lightning protection rod to a location at least 6 feet away from any service rods. This is a critical step in minimizing interference between the rods and ensuring that each functions effectively. Secondly, ensure that all grounding rods are properly connected together with a copper bonding conductor. A copper bonding conductor creates a low impedance path for fault current to flow, which is essential for proper grounding. This conductor should be sized according to the National Electrical Code requirements and securely connected to each grounding rod. Thirdly, have the grounding system inspected and tested by a qualified electrician to verify its effectiveness. A qualified electrician can perform tests to ensure that the grounding system meets the National Electrical Code requirements and is functioning properly. These tests may include ground resistance measurements, continuity tests, and visual inspections.